cappuccino, hold the phone, take me home. Morning coffee, vanilla latte served to go. I drink it slow. Morning coffee, cappuccino, hold the phone, take me home. Morning coffee, vanilla latte served to go. I drink it slow. Morning coffee, cappuccino, hold the phone, take me home. Morning coffee, vanilla latte served to go. I drink it slow. Morning coffee, cappuccino, hold the phone, take me home. Morning coffee, vanilla latte served to go. I drink it slow. Morning coffee, cappuccino, hold the phone, take me home.
What up, everybody? Welcome to another coffee hour. My name is Paul Abernathy. Got the coffee, got Mickey, and we're gonna do a commentary on tonight's episode of Coffee Hour. So thanking all of you for taking the time out of your busy day. It's been a literal blizzard here in Texas, all of about maybe a half an inch, maybe, but it is freezing everywhere. So hey, there you go. Need to be concerned with all that freezing rain and all this other stuff out there. So, but again, welcome to another episode of Coffee Hour. Kind of a spontaneous one. As I told you, I get the free time, and when I get that free time, I like to do a coffee hour. So Hopefully you've got your coffee. Doesn't matter what time of day it is for coffee. It's always a good time. So hopefully you are ready to get started with us. And we're going to look at a residential installation. Now, let me give you a little of the front story here. The individual that we'll be critiquing or giving commentary on today is not an electrician, right? So he's not licensed. And in many states, you don't have to be. You can do your own work. If it's your building, your house, or whatever, you can do your own work. So at the end of the day, this individual is doing all their own work. And so they don't have to have a license. Now, we'll tell you up front, this series is not like the electrical blunders. Here, we're doing commentary to try to help educate, spread some information, do our best to add additional info that might be beneficial for you if you're watching a video, and you can learn from it. And so I will do my best to add commentary where I can in the video to give a little more insight. So hopefully you're all buckled up and ready for it. So we'll go on and get started in it. Okay. All right. So let's go on and jump to the actual video. All right. So here is our individual for today. This gentleman, I will tell you up front, does not do a bad job. So we'll be critiquing it a little bit and, throwing a little extra code references out there. We do have a new cam in the house. So as you can see, whoops, right there, we have a new cam, overhead cam right there, codebook cam. That's what I should say. There you go. We have a codebook cam, which is struggling to focus. That's okay. We need that, especially if we're going to be looking at some fine print or whatnot. So anyway, we've got that going on. So let's get into it, and we'll get this gentleman started. And again, you can post your questions if you have any. I'll do my best to answer it. Probably keep them germane to the topic. I mean, again, we're talking about services, and we're talking about this gentleman's installation. And so, yeah, let's try to keep it at that, if you will. Hopefully you'll enjoy it. All right, so let me go on and get on this one.
In this video, I'm going to show you how to wire a main electrical panel.
And
the panel I will be installing is this 200 amp square D breaker box. And if you're new to this channel, my name is Josh. This channel is all about building your own house saving. Tell me, be sure to subscribe, ring that bell so you get a notification every time I release a new video, and hammer that like button for me. That's all I ask in return for making this video. So we got a lot to get into today, so let's get started. This breaker box is made by Square D, and it's a 200 amp, 80 circuit, 40 space plug-on neutral box, and it's the home line. And this is very nice because you will not have to use pigtails to hook up your neutrals. So let's check out everything that came with this breaker box. So we got some instructions. We got this bonding screw. You definitely want to hold on to that. You may need it. We got these lug covers. By code nowadays, they want you to have these over these main lugs, which is very important for safety. And then what we got here at the bottom of the box, looks like we got an assortment of breakers. Looks like we got a double 30, we got a single 20, single 20, single 20, and a double 30. And these are not arc fault or GFI, they're just standard breakers. And then if we set this out of the box, this is our panel cover, and obviously after we're done installing, we will be putting this over it, and this comes with the screws to anchor it to the actual panel box. Before you watch this,
I should tell you though, it's very clear that is a one of those contractor sets where you get the panel and everything, and you get an assortment of breakers in it. So Home Depot, Lowe's, whatnot, gives you that assortment. Sometimes comes out to be much better than if you were to go price it at a supply house and try to get it and buy the individual breakers. So they throw in some breakers. Usually there'll be like a 32 poles, some 15s, maybe a 1 or 2 20s. But hey, you got to have them anyway, right? Okay, so again, there you go. So let's get into it. All right.
This full video, and for full disclosure, I am not a licensed electrician. In the jurisdiction I'm building this house in, if I do my own wiring, as long as it gets inspected, it's totally fine. So everything I'm doing here is going to be thoroughly inspected. And with that being said, I have wired 4 houses on my own and they all have passed inspection with no problem.
All right, so that means we're gonna have no problem today. And probably not an aluminum bus, probably a coated bus, that type of thing. So.
And I just wanted to let you know that, so this video is for entertainment purposes only. I'm going to be installing this breaker box in this stud space right here. If you measure the width of this breaker box, it's 14.25. And a wall that's 16 on center is going to have 14.5 from stud to stud. So it's actually designed to fit right into a stud space comfortably. And if you look here, I got my SEU cable coming in through the wall. And if you need to know how to install your meter base in the SEU cable, I'll put a link up above here. It's a video I made of me doing that. So it's going to elbow up into the breaker box. And now the breaker box can be flipped upright like this. In most cases, people think that the breaker has to be at the top of the panel, but these square D boxes in this model can be flipped upside down or even sideways.
All right, so let me clarify that. Right, so that we're all clear on what he's talking about. Yeah, so sometimes you can orient your panel either way, it doesn't matter. The thing you have to worry about is the main breaker. So if the main breaker is not horizontally but vertically switched, then it has to be on in the up position, right? So that's an issue. So it has to be 240.81 on in the up position. And so it has to be up. We can go look at that in the code, but I think we all get that. So you have to be careful. Now, most of these panels like this, it's going to be left to right. Okay, so it's going to be a horizontal movement. So it really doesn't matter at that point. If it is on in the up position, right, then it's got to be on in the up position. So most of the manufacturers know this. They produce them, and they were going to put that main breaker, and it's going to be more of a vertical. But they are the ones that are the up. Okay, they actually go up and down. So if that's the case, you got to remember that orientation in the code, right? And that is 240.81. Of course, we could go to the NEC. Look at that. So here's our NEC. And we could go to, let's see here, 240 down here. And I'll just scroll down. We don't believe in the search feature here. So we're going to scroll down and indication right here. All right. So circuit breakers shall clearly indicate whether they are open, off, or closed on. The circuit breaker handles operated vertically rather than rotationally or horizontally. The up position of the handle shall be the on position. Okay. So yeah, you can put them either way, upside down, right side up, whatever. But you have to be aware of that main breaker. And if it's on, it has to be on in the up position. So keep that in mind. Most of them are horizontally activated, so it doesn't matter at that point. And that kind of gives you a reason why you can do it either way. Now, he also talks about sideways. Be careful sideways, because nothing that says you can't do that, right? You still have the on and the up position issue. And it also means that because of the way your bus works, when you're turning the breaker on, they all go to the inside when they're on. So if you turn it sideways, the only ones that you can use are the breakers that are on in the up position. You wouldn't have to be a whole side you couldn't use. So, nothing says that you have to do it up straight up, or you could even do it sideways. The one thing the code does tell you is that you cannot have it. 408.43 tells me that I can no longer have a panel in the face up position, with the breakers pointing to the sun, that type of thing. So that's in the code, right? But other than that, you just have to be aware of that orientation. Okay. Let's get back to it. I don't want to take any other time away from him. This is a 40-something minute video, and I want to make sure I don't turn this into a 5-hour thing. So here we go.
All right, let's go ahead and prepare this box for installation. If you're going to be installing this in a stud space like I am.
I should also mention real quick that when you are putting it in the wall, just be careful, because the main breaker, the maximum height is 6'7", okay, to the center of that breaker. So again, if you put it up with the breaker on top, the main breaker at the top, for example, then you have to be very conscious of the height you put it at. People ask me all the time, we have that height, but how low can you put it? Well, there is no rule in the code for how low you can put it, except for when you're dealing with things like mobile homes outside. Okay, so it has to be at least 2 feet off the ground. but you know, for obvious flooding and whatnot, snow buildup or whatnot. But inside the building, you know, we set things like ADA. People put them down low. We have the height limit on the breaker, but we don't have how low it can go. Yeah, common sense should rule the day here. But just wanted to throw that extra stuff out there for you. Now, the rule for 6'7", in case you're looking, we could go to the code, but we're going to talk. It's also a switch, right? And since it's a switch, 404.8 comes into play, and that's the rule for the switch height. Okay, not higher than 6'7" to the middle. All right. Anyway, just extra info we'll throw out there.
Take note of the little holes that's up in the corners inside of the box. There's one, and there's one down here. And then there's one back in this corner, and there's one down in this corner. And they all can be taken out by taking a screwdriver or a punch and just holding it right into the hole and tapping on it, and it'll knock them right out.
Man,
The screws are going to be used.
he is quick. Let me tell you what. He's
Using to anchor this panel box, these engine 5/8 wood screws with a washer attached to the end of them. I know a lot of you guys know I work alone, so I'm going to hold this panel box up in place the best I can and put a screw through the side to hold it until I get a ladder to finish the rest of the screws. It's always fun laboring by yourself. I always like to use a level to double check to make sure we're plumb. And looks like it's pretty close. Just got to draw that screw in a little tighter first.
All right, the only other comment I will make on this is he has to be careful because, and I don't know what height is, and we're just speculating. It's always an issue of speculation, right? When we're giving some of this commentary. But one of the things I will mention is that it seems pretty high. So if he's planning on using the breakers from the top down, be careful that that top breaker doesn't get more higher than 6'7", because it is also a switch. So 404 or 404.8 and A, that's going to be our 6'7" that you can't exceed. So I want to assume he's not, and you know how he's going to lay his out. But also turning and putting the main breaker down low, it is less SE cable coming into the actual structure, and we'll talk about that in a second. But okay, so far so good. All right.
Now I have the electrical panel set into place, and as far as the height requirement goes, the inspectors here don't like to see any breaker higher than 6'7", so that's just something to keep in mind. Check your local jurisdiction to see what you'd have to do if you go to install your own panel box.
If an electrical inspector lets you be higher than 6'7", they are assuming that responsibility and liability. Okay, code is a minimum safety standard, but that wouldn't be adverse to the minimum safety standard. That would be in violation of the minimum safety standard. You get what I'm saying.
All right, let's go ahead and install this SCU cable into this box. Next, what I'm going to do is install this 2-inch clamp. It's going to hold the SCU cable. So it's going to come up through the center here, and if you lay it down into place, it looks like this knockout right here needs to come out to accommodate this clamp. So what I'm going to do is just take a screwdriver, a straight screwdriver with a hammer, and just tap it out.
Don't worry, everybody. It doesn't look like it's one of those fancy Klein screwdrivers. Probably just a Harbor Freight screwdriver. I know. I have plenty of them. Just saying. Bang away. Bang away.
Now,
I do want to give a shout out to everybody in the room. Elwood, Joel, Schwartzy, okay, Adam, Matt. Thank you all for joining me. If you're in the room and you're quiet, speak up. Let us know where you're from. Talk to me. This is live. This ain't recorded. Holla.
I'm going to take this 2-inch clamp, slide it up into the hole, and you want to make sure the screw heads are facing towards you so you can tighten it up here in a bit, and then tighten up the nut that it came with. And then after that's tightened up, you just want to take a bushing. This is a 2-inch bushing, and it just goes over the end of that.
Okay, a couple things, and y'all knew it. Y'all knew I was going to say this. That bushing is not a requirement. Now, I get it. What's up, Skip? Thanks for joining us. All right, look. That bushing is not a requirement for cable. It would be a requirement for raceways, but not for cables. Now, I can hear somebody out there saying, I know, but the code is the minimum. It makes you feel better. if you put that bushing on there? Well, you go for it. But you got to remember the 300.4G in the NEC is about raceways, not cables. So if you want to do this, this is purely something that you want to do. And if you want to do it, that's fine. But remember, the code requires that that cable is connected and secured to the box. Okay, in this case, the cabinet. All right, it's not going anywhere. So there's not an issue that you would have the same as if you're pulling conductors in there and things like that. So that's why the rule. Now, again, if you want to go above code and do it, you're perfectly okay. Go for it. I just want you to understand that that is not required, okay? It's not required, okay? Now, you call it a beater Elwood. The problem with this is we call that bushing, if we were going to pull conductors in it, some of us call it a knuckle protector and all that kind of stuff, but it is not required, okay? Okay? So that type of scenario. All right? So the rule on that, you have to go look at 300.4G, okay? We're talking about installing the cable in that clamp, right? That type of scenario, all right? The other thing about it is if I were to pull a cable inside of that raceway, like you're mentioning, then I still wouldn't require it because the rule in 300.4G is talking about insulated conductors pulled in the raceway. So I'm not going to have a requirement for that either. But you know what? If you want to use them, go for it, okay?
And all that does is just keep those edges from damaging the cable going up through it. Now it's time to wrestle this 4-aught SEU cable into that clamp. This can be challenging because this stuff's like fighting a bull sometimes. All right. But we're not going to let it win today. There we go. Not too bad. This clamp requires a square drive, and now I'm just going to hold that into place and tighten that up. And you want
Let me make a couple observations here for those that might be wondering, so when is this installation? Well, this original video, which mind you has over almost 500,000 views, and we don't know what jurisdiction he's in, right? We don't know. But I like to throw these observations out there. Couple things. Number one, since he's putting this panel inside and there's the main breaker and he's using SCU, that tells me that they're not under the 2020 edition of the National Electrical Code, or maybe he is and he's going to get rejected here shortly. But reasoning is because there's no emergency disconnect outside, right? And so we're required to have that emergency disconnect in 230.85 of the 2020 NEC. Well, he does not have that here, okay? So we know that kind of might tell us where he's at. Things to think about. The other thing is some places in some jurisdictions, he might have an issue with how he mounted this and not running that SE cable directly into the actual panel. And so he has a certain amount of it exposed into the wall. And so in some jurisdictions, because the wording of the code says in 230.70A1, it says outside or nearest point of entry. Well, some jurisdictions will let you have a foot, a 2 foot, a 3 foot, because to me, the most restrictive enforcement of that would be it's got to come straight from the meter or straight from a disconnect, straight in. Now, if it's a disconnect outside, then it's a feeder, it can run further. But when there's service conductors like this, you're limiting the length that can come into the building. Now, I'm probably somebody that's not going to give them a lot of heartburn about this, but there are a lot of jurisdictions that will, because that is unprotected cable running in and up into the building. So many of them will say, nope, I want you to keep it outside until you penetrate straight through into the back of that cabinet. Again, every jurisdiction's a little different. I know plenty of jurisdictions that'll let you go up to 3 feet inside of a building. I know others that will let you go none, right? You got to come straight into there, or you're going to have to put a disconnect outside. So now it's a feeder, and then we don't have any restrictions as you go through the building, that type of thing. So, hey, these are just things that you need to think about, right? But this just tells me that he's probably not in the 2020, although our commentary is going to be probably close to 2020. You know what? That looks like that's probably rigid, not Ryobi. But you know what? I ain't hating on Ryobi. I love Ryobi. I'm just saying. Okay, I don't buy into that fanboy stuff. All right, so So anyway, that's just my observations here. Another one I'll make is that probably that 2-inch connector is probably larger than he needed for this installation, right? Okay, just saying. But it works, so he's going at it. So let's get it go. I don't want to turn this into 4 hours.
I'm gonna tighten each side equally. So always draw each side down a little bit at a time. All right, that looks really nice. Now just go ahead, flex this down a little bit, and take a utility knife, and we're gonna strip that casing off. Just go through the casing just enough to score it pretty good.
Of course, he says casing, we know it's sheathing, but he's not an electrician. But he's doing good so far. You know, even the bushing, you just spent a little more money than you needed to. But hey, he's okay, right?
Don't press really hard because you'll cut into the wire that's underneath the casing here. All right, and after you get it started, just start peeling it back. And then I always try to get as close to that clamp as I can get it to. Okay, and always get this wrapper out of the way. Okay. Now what you need to do, just go ahead and separate those wires and then twist all these loose aluminum wires together. And it's going to create its own individual wire. In this case here, the red and black can be on either side, so it really doesn't matter. But what we need to do is go ahead and get those cut to length first. So I'm just going to hold it up roughly where it goes, and then go ahead and mark it with my utility knife where it needs cut. So that one's there. That one's about here. And whatever you do, don't cut it too short. And this one's going to be right in there. And I got to use pencil on this one because you cannot see a scoring on it. Now what I use is a Sawzall. This is actually a Job Max. This is a small Sawzall, but it'll still do the job. So what I'm going to do, go ahead, lean this over.
So most of us in the trade, I mean, Sawzall's fine, but most of us have the ratchet cutters. You know, I had mine. We were all proud of our ratchet cutters, you know. Pop, 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 pop. That type of thing. But yeah, at the end of the day, he's using a Sawzall. It's all good.
Over to where it needs cut and cut it.
You know, if Jay was here, Jay would say, Elwood, you're going to get me banning you tonight. You want me to just block you? I'm going to block you in a minute? No. If Jay was here, you know, he would say he likes how they speed up the video. You know, like, don't belabor it. You know, he would love that.
So what I'm going to do now is strip the sheathing or casing, whatever you want to call it,
That'd be insulation, right?
wrapped around these cables. So I'm going to hold them up about where they go. Go ahead and make a mark with the utility knife and just score the plastic on the outside.
Relax, folks. He's not going deep enough to score the conductor. He's just scoring the outside. Relax.
And that way we know how much to take off. And then to strip it, I just put the utility knife into the actual casing and just go around it, and just enough to score it pretty good. And then after I do that, I just put my utility knife into it, just enough to score the plastic on it.
I'm not too keen on his utility knife cutting skills, so just stand back and let him have at it, right? Okay, that type of thing. We all know what it is.
Usually go lightly over it a few times. Okay, and now just go ahead and start prying that casing off, and it should pop off, and you know, you'll get the feel for it after you do one.
Quiet, Elwood. You're a troublemaker tonight.
Now what I'm going to do is back these lugs out so that way they're not in the way when I go to install the cable into them. And if you're wondering, this Allen wrench is a 3/8 inch size.
Yes, he does keep saying cable, and these are individual insulated conductors. I get it. And then, of course, one uninsulated conductor, but we know what he's talking about.
In case you buy this exact box, that's what size wrench you're going to need. Okay, and now what I'm going to do is I'm actually going to loosen up this clamp enough to drop this wire down a little bit just so I can slide them up into place. All right, so I'm going to just loosen that up some. All right, so that loosens that wire up so we can work with it. So now what I'm going to do is drop it down a little bit and then take this product. This is called OxGuard. This is an antioxidant compound that keeps these aluminum wires from oxidizing too much. And then there's the other brand by Ideal. This is Noalox. They're both.
Okay, y'all ready? Are y'all ready for me now? Okay, let me get a coffee before I dig into this one. So this is an example where you can go over and above code if you want to. Okay? Antioxidant compound is not required on these aluminum conductors. But you know what? If it makes you feel better, it puts that warm and fuzzy on you, then do it. But it's not required. Now, again, I hear everybody always say that, well, you got to do it because that's what the manufacturer states. None of us manufacturers require this. We don't test our wire with this. If you want to do it, you can. So I figured it was a good time because, again, I do hear this all the time about the antioxidant compound and it's required by the code. And the only time it'd be required is if the piece of equipment required it in its literature. But other than that, the Aluminum Association makes a recommendation that you use it because, again, we want to protect their interest. Manufacturers will recommend it, wire and cable. We don't care whether you use it or not, but if you're going to use it, we're going to promote it. We will tell you to use it for both copper and aluminum because we don't want to alienate one over the other because we usually represent both of them, so we don't want to tick them off. So we'll tell you, go ahead and use it if you want. The key here is when you torque it, you terminate it properly, then you don't have the issue of air getting to the contact points to cause the oxidation to create a problem. So you leave them unstripped if it's going to be more than a day or two or whatever. Just leave the insulation on it all the way up to the ends. You wouldn't do this and you wouldn't expose it and then leave it like that, right? You just wouldn't do that. In this case, it's not sitting out nearly long enough for it to oxidize, so it's not necessary. Once you torque it, then you're going to make that contact to contact, and that's where the rubber meets the road, right? Because any of this other conductor that oxidizes is no harm, no foul. Like the rest of that bare aluminum, if it oxidizes, who cares? Who really does? It acts as a protective layer. So we're only worried about the termination, right? So if we go to the National Electrician real quick, and we go looking at the code, what I'll do is I will take you up to the top and I will explain this to you so that we never, ever, ever, ever have to explain this again. It'll be done forever. All right. So here's what we're looking at right here. 110.14, the last part right here. It says materials such as solder, fluxes, inhibitors, and compounds where employed, not requiring you to employ them. Where you do employ them, they shall be suitable for the use and shall be the type that will not adversely affect the conductor's installation or the equipment. Now, years ago, the antioxidant compounds were specific to copper or specific to aluminum, and compounds had stuff in it that could cause a galvanic action or something. But that's changed now. They're all petroleum-based now. They're not going to have any adverse effects on these conductors. Obviously, it's what it's designed for. But this says where they're employed. Now, if a manufacturer requires it in their literature, posted on their legend, and it says you got to use it for aluminum, use it. If it doesn't, it's totally optional. It's up to you. And again, it's some people, they would find. Now, for this gentleman, the key question for me is whether or not he's going to follow torquing rules. Because if you don't follow the torquing rules, then it's irrelevant. David, if you don't like it, there's the door, buddy. You don't have to stick around. You can leave. I can kick you out. Either way. So that's a choice. He's making the choice, right? Okay. All right. So that's the rules on that 110.14.
The same stuff, so either one's fine. So we're just going to go ahead and take this little tube for convenience, and we're going to smear some all over these cables here. Now we're just going to push them down and then slide them up into those lugs. So once they're up in the lugs all the way, just go ahead and hold some tension, make sure they're up really nice, and go ahead and snug these up.
Snug them up. So it is safe to say.
And then just tighten up your clamp again.
So it is safe to say that he is not going to use a torque wrench here. So it's safe to say that nowhere in the rest of this video is he ever going to use a torque screwdriver or a torquing wrench. And I know you all do, right? Okay. But at the end of the day, that is a problem. If you don't torque it, you have more. I have less concerns about oxidation, right, than I do with torquing. Torquing is critical. That is the weakest link in an installation. When I get calls about installation that breaks down or terminations or fires, it usually is somewhere wrapped around a termination. So torquing is there for a reason. Everybody thinks that torquing was all of a sudden just came into the code a couple cycles ago. You know, 110.3b has been in the code for decades. And if the manufacturers, in that little label, you see a little piece of it, if it requires torquing, right, whether it's foot pounds or inch pounds, depending on what termination it is, then you have to follow that. And I think that if I had to say what's the number one thing people probably don't follow in the code, it's probably torquing, right? 110.14d gives us those rules, but people just don't follow it. Before there was 110.14d, there was 110.3b, and that was install it per the manufacturer's instructions, right? Okay. I think we all get it, but chances are he's not going to torque a thing here.
And then we are now connected to the actual panel box. And now let's go drive some ground rods. So before I install any breakers in the breaker box, I go ahead and get the ground rods drove, run the copper wire, and that panel box is on the other side of this wall. So
it's obviously very clear that this either must not be a 2020 installation because we have no emergency disconnect outside. So wherever he's at, it obviously not the 2020 code, right? So that's just evident here. We verified that, right? I always torqued everything I did. Everything. I torqued everything because, as you know, Paul can't do it anymore. He's just an old online code guy. He never did any installs, ever, in his life. Okay? Just saying. That's what the rumor is. Right.
I'm just going to be drilling out through the side of this wall and running over to this first ground rod. And this...
Hey, another thing I'll mention, you'll notice that he has an expansion fitting on there, and probably from utility required it. But that expansion fitting that it has, probably for ground movement, 300.5J. And so there's an expansion fit on there. So people have asked about expansion fittings. Either it's required by the utility or it's historical in the area that there's ground movement, seismic or something. And which might mean maybe he's in California, whereas they're still on the 2017 code, which would explain it about the emergency disconnect issue. But that's expansion fitting, allows it to move up and down if you have some earth movement and whatnot like that. So just figured I'd call that out. So because I see one that he has there. Okay.
This is going to be drove straight down, and I got another ground rod here, and it has to be at least 6 foot apart. You can go a little more if you want, but it has to be at least 6 foot apart. So I guess the idea is so you get plenty of ground coverage. So in order to do this, we're going to come up here with these 2 huge hammers. Just kidding, I'm going to throw this one down. That's for later when you get into really tough ground. So we're just going to go ahead and start driving it straight down like this. Slowly but surely. So I'm going to go ahead and drive these down, then I'll show you how to put the grounding clamps on after that.
This is a great time to mention Ronbo. If y'all know Ronbo, who comes on sometimes to our chats and comes on to some of them. And, you know, he made this little device here, which is his driver. It slides over the ground rod. And again, it would allow you to get a more wider berth of swing, I guess. Put this over the ground rod and you got all this nice platform here. They make all kinds of these. But this is from Ronbo. He makes these, and he put it right over the end, and you can just whack away at it, right? Like that. So obviously his ground's not too hard, so doesn't have any problem. But, you know, this is what we're talking about. This would be slide this over the ground rod and just whack away. You also have less chance of destroying the end of the ground rod, which is usually tapered. And I used to use a hammer drill, but you remember I don't do work anymore. So, but I use a hammer drill, and a hammer drill would do it. And to answer also your questions, just to be all transparent, I did torque all of my service, and I torqued my feeders. I did not torque branch circuits. I'm down to the, in a panel I would with a torquing screwdriver. In fact, I have a video of me showing one, but I did not do it on receptacles and things like that. Just didn't do it. So I'm just saying, when it came to services and feeders, I had a torque wrench and I used it. And if you want to see it, I still have one, and I will do it on another video. That's where it was more critical for me than it was downstream. That's not to say that we don't have torquing requirements on everything. I get it. But typically, when asked how I confront that with people, I tell them at least do the services, at least do the feeders. Those type of applications is where I'd want you to see torquing and, you know, to stick with it. When it gets down to the receptacles and all, at the end of the day, whoever posted that, you're just being a smart ass. So that's where we would typically do it. Okay. Lord knows I got a lot of smart asses.
So now that the ground rods are in, I got to run a bare copper wire to the panel box. This is 6-gauge copper wire. So in order to do that, I need to drill a hole through the side of the house to get outside. So I'm just going to offset it right beside the conduit that's going up to the meter on the outside, which is right here. All right, now we're going to go outside and hook this wire to those rods first and fish it into the house. Here's the hole we just drilled in the side of the house. Now the copper is going to run along this conduit into this little trench I dug, and then here is the grounding rod that I just put in. And it's going to follow this other trench 6 foot over to this other grounding rod. I'm going to show you how to connect.
And by the way, I can tell by the tar how much that's up like that there's actually going to be a backfill, probably about a foot of backfill on here. So he's even with the grade and is obviously going to be below grade ultimately anyway. But he drove them down pretty good, and he looked like he cupped it out. So no problem with that.
Connect to these rods using these universal grounding clamps. And I just got this for only about, I think they're about $5. So I'll put a link in my description below to my Amazon store where you can find a lot of the products that I'm using for this installation. First, just take the grounding clamp, back out the bolt that's on it, and then slide it over the ground rod. And then take your bare copper wire. And I got 25 feet here, which I didn't need that much, but they were out of the wire that's on a spool. Anyways,
no comments.
So just take the copper wire.
No comments from you, Elwood.
Wire, and just pull out a couple feet of it here, and then take it and make a little bend in it, like a hook almost, something like this, and then slide it down beside the grounding rod. So
now, just a little comment. I would do this the other way. I would go from underneath and push it up, and then what I usually would do, and I'm pushing it up, and then I would wrap it over, kind of just wrapping over the fitting. But again, you can push it down. It doesn't really say, but he is putting it on the right side. But instead of just poking it down, they have a tendency to work loose. And so I usually make an L and pop up underneath it and then wrap it over. That's just me.
It kind of hooks on to it, something like that, and then just go ahead and tighten up that clamp. This is just a 1/2 inch socket to tighten it down all the way. And don't over tighten it to where you strip it out. And now just go to the next one and do the same thing. Sir,
those things are cast too, so if you really torque down on them things, you will snap those things right at the weak point.
here we are clamped to this furthest ground rod. Then it runs over to the one closest to the panel box. And just an important note, you do not want to cut these bare copper wires. You want to keep it all one whole strand. Don't split.
All right, so I knew somebody would make a comment about that, and my response to that statement that he made is it does not have to be continuous from the furthest ground rod through the closest ground rod to the panel. It says the code rule for 250.53A2 is that second one is a supplemental. If the first one doesn't achieve 25 ohms or less, you have a second one. You start out with 2, right? And you can drop down to 1. So the grounding electrode is that first ground rod. The fact that he's got 2 is because he can't prove it's 25 ohms or less. So you're required to, with a single rod, you're required to supplement it. Okay. So it does not have to be continuous from the panel through that ground rod clamp to the next ground rod clamp. No, that is a bonding jumper from that ground rod to the other ground rod. So I could put 2 clamps if I wanted on this rod and have one for the one from the panel and then have one for the bonding jumper between ground rods if I wanted. Prove me wrong the way it is. So now, if you want to run it continuous and that way you only have to buy 1 clamp for that rod, perfect. Go ahead, save your clamp. Again, you could have saved a bushing earlier, right? And of course, now you can save a clamp by doing it this way. But remember that it's continuous to the electrode. There is one electrode. The reason he has the second one is because you're required to supplement a single grounding electrode. That's a rod type, rod, pipe, or plate. So if you go look at 250.53A2, what he's doing is he's supplementing, and that's why he's got the 2. So it doesn't have to be continuous all the way through. You can if you want, but it does have to be continuous except for irreversible crimp or like CAD welding and things like that, which you could do if somebody cuts your grounding electrode conductor. But typically it's continuous from the panel to this first ground rod, but it does not have to be continuous to the second ground rod if you're adding that second one as a supplemental to the first ground rod. Okay. All right. So there you go. Question in there is about the requirements to protection of the equipment grounding conductor. Well, this isn't an equipment grounding conductor. This is a grounding electrode conductor. And there are rules in here if it's subject to physical damage. So if it's smaller than 6, you have to always protect it, like Schedule 80 PVC. If it's 6 and larger, it only has to be protected if it's subject to physical damage. If it's not subject to physical damage, then it doesn't need to be protected that way, okay? So it all depends on the install and where it is. But again, if it's smaller than 6, then it's always going to be protected. If it's 6 and larger, you only have to protect it if it's subject to physical damage. Now, there's no definition of that in the NEC, so you're going to have to look at where you're installing it. And the little joke I always tell people, if my ground rod was on the side of my house and my grounding electrode conductor was on the side of my house and my wife is driving, it is always subject to physical damage. Always. If you've ever seen her drive, you'll know this is the case, right? So, you know, but AHJ will make that call. You're going to have to use a common sense call. If you're running it with the surface of the building and everything like that, then I really wouldn't consider it subject to physical damage. But again, AHJ is going to be the rule on that.
Splice it together or anything. And then we're just going to fish the rest of it into the house. I'm going to leave those grounding rods uncovered until inspection. And they should be about a foot below grade by the time it's backfilled. Just so you know. I know some of you guys are probably wondering, is it okay to use number 6 copper to ground a 200 amp panel? Well, in my jurisdiction it is, but be sure to check your local building codes because some areas require number 4 copper, which is a bigger gauge than this number 6.
So again, if a jurisdiction requires larger than a 6 to ground rods, This is one of those things where you probably could challenge them because the code's very specific in 250.66a. If you're just going to ground rods, then it doesn't have to be larger than a 6. Can it be larger than a 6? Absolutely. Hell, they could do what? Joel, we don't have to prove 50 ohms. It's 25 ohms or less, not 50, for ground rods, pipes, and plates. And it only applies to rods, pipes, and plates, by the way. So in this case right here, 6 is all you need. A ground rod, I like to tell people it's like putting 10 pounds of crap in a 5-pound bag. It's not going to fit. Ground rods can only handle so much. And 6 gauge has been tested and it's perfectly adequate for it. So that's why 250.66a deals with that and says it doesn't have to be larger than a 6, okay? Now, people say, well, a 6 or a 4 aluminum, but again, you're not going to be able to run that termination within 18 inches of the earth anyway, so when we're talking ground rods, it's kind of a moot point. Really going to run copper, and it's going to be 6 gauge, that type of thing. Now, could an engineer make it be bigger? Absolutely. Typically, engineers aren't going to be involved in a residential anyway, so it's going to be your call, right? That type of thing. Right? But if you did something different, like you kept it up high above 18 inches and you were doing the allowance for a common termination where you can bring other things to it, then you could use an aluminum and you could take it to that bar and then everything else would connect off of that, right? So there is some options for that, but typically a ground rod, residential, that's what we're talking about today. We're not getting into the what ifs of whatever could be done. In this scenario, he's just going to his ground rods. We saw what he's doing. Doesn't have to be larger than a 6.
So I just wanted to let you know that before you go out and buy number 6 copper for your panel. Always check your local building codes. In order to get the ground wire into the panel box, there's a little knockout right there. Go ahead and knock that out. And sometimes you can push them out. They're not secured very well. And we're going to fish it right up into that hole. All right, so we're just going to fish it right through there. And as you can see, there's ample amount of room to get the ground through. And now what we need to do is cut it to length, so it should go to about the top of that lug once it goes in there. So we're going to go ahead and snip it about right there. And this is soft.
That's why we always have that little 6-inch piece of 6 gauge, because you didn't, you know what you could have done? You could have pulled in enough and made that termination and then pulled it out, and then you could have made your connections to your rods and, you know, all that kind of stuff. But you're always going to have that little piece. Okay.
Copper, so it cuts really easy. So now what we need to do is back out this slotted lug right here. So just get a straight screwdriver, back it out some, and now fish that ground wire right up into it. And now, after it's up in all the way, go ahead and tighten that down. Since this is not coming from a disconnect or is a sub panel, I got to install this bonding screw into this hole right here. So in order to do that, you just take a square drive and just simply slide it into that hole and keep tightening it down.
So you want to know where to invest $1,000?
Okay, we got the commercial. Got to pay. He's got to pay the bills. Got to pay the bills.
A little
until it is snug, and that just bonds the panel box and everything together.
All right, so that's the main bonding jumper. The rules in the code for sizing a main bonding jumper is 250.28. Of course, this is a screw, green finish. You don't have to size this, comes with the panel, no sizing involved. But if you did have a main bonding jumper that was of the wire type, then you're gonna have to size it, right? And 250.28 talks about main bonding jumpers, right? And it ultimately sends you to where? 250.102C in order for sizing. So kind of keep all those things in mind, but in this case, it comes with the green screw. Use that green screw, boom, done it, easy peasy, no calculation involved.
So before I get a bunch of home runs coming down through here, I'm going to go ahead and take this half-inch drill bit and drill about 10 holes through this wall where the double plate is here, because it's way easier to do it now before you have a bunch of wires in your way and you got to risk damaging the wires. So I'm going to do that and install a board going across this stud space, because I got to anchor the home runs 12 inches from the panel box. So I'm going to put it here about 6 or 8 inches, and so that way we know we're good. And then they're going to have them run down into the panel box from there. Let's go ahead and do that.
So while he's doing this real quick, a lot of guys out there hear me talk about the securing and supporting requirements in dot 30 of most of the wiring articles. This is an example where he's going to be running SE cable, like the cable he ran below. You don't have a dot 30 for SE cable. So what you've got is 338.10, and that's going to be the uses permitted. And that's going to give you permission in there. And that's going to tell you that you have to secure it within 12 inches. So kind of no, but anywhere else you would get .30, like non-metallic sheath cable is 334.30. Okay. MC cable, 330.30. AC cable, 320.30. When it comes to service entrance cable, nah, it doesn't have it. It ends up sending you to part 2 of 334 because it's just like a non-metallic sheath cable on steroids, right? That type of thing. So he's running his SE cable, and he's going to secure it within 12 inches. But I don't want people to realize that there is no .30 for those students out there. There is no .30 in 338, but ultimately it's under the uses permitted, which sends you to part 2 for 334 for non-metallic sheath cable. And also remind you, this guy is not an electrician. Okay, so I think he's doing pretty darn good, if you ask me, for somebody so far who's not an electrician.
So now above the panel box is ready for the home runs, and below what I got to do is secure this SEU cable against this block of wood, again within 12 inches of the panel box. And then we're going to address this hole here in just a moment. So to do this, I just get a piece of strapping and a couple short decking screws. You don't want them too long to where they go through the side of the house.
Now, some AHJs will have a fit with this, right? And they'll say that strapping is either for plumbing or whatnot, and they wouldn't allow it. Some people are like, I want you to use SE straps or whatnot. Again, I'm neither here nor there on it. If it's a strap and it's securing it, it's holding it in place, I really don't care. Yeah, that type of scenario. But again, being aware that some jurisdictions, they might say, no, I want you to use SE straps, service entrance straps, and okay, I get it. But I personally have no problem with him using the strap here because it's going to make it pretty darn secure, and that's all I'm concerned about is it's not moving. I will say, though, in a lot of the jurisdictions that I was in, this would be too much SE cable in the building, but a lot of the little smaller jurisdictions did their own thing, and they allowed up to 3 feet, sometimes up to 6 feet. So, again, always check your jurisdiction, and all straps are not required to be listed, by the way. But in this case, here he goes.
So all we got to do is strap it just as if you're going to strap any kind of plumbing or duct work. So we're going to get one side started here. Now I'm just going to put tension against that SEU cable and go ahead and draw this screw down.
I am impressed that he does call it SEU, right? He could have called it anything, but he does call it SEU. So.
And now that's going to be held securely before it goes into the panel box. So we like that, and always put the ground into that same strap, just kind of keep it looking nice and organized. So now what we're going to do is take this duct seal and pack it into this hole so we got a nice weather tight seal. And this stuff can be found in my Amazon store. Just check the description below if you need.
All right, so here's another thing that comes in. So a lot of people say, is this required? It's not necessarily required. The 300.7, which is temperatures where you might have different temperatures and things like that, that's typically for raceways and sleeves, not really for cable assemblies. And if you go look at 300.7, it'll state that it is for raceway or sleeves. But at the end of the day, you know, there's absolutely nothing wrong with sealing that up. If it was a top plate or bottom plate you're drilling through, we're going to maintain the rating of the assembly. In this case, it's not what he's using it for, but it's still a good rule. It was an awful big hole he cut. So again, it seals it up, keeps moisture from getting in and all those type of things. But when we're talking about the temperature issue, and some people want to cite 300.7 for that, and you can go look at 300.7, that's not what he's doing this for. And this isn't a raceway, obviously, again, but go. And then the question on workmanship is not defined in the NEC, so it's in the eye of the beholder. Looks pretty good workmanship to me. I don't have any problem with it.
Need to buy it. So you simply just take this like a piece of Play-Doh, kind of stuff it in and seal around that hole. And it
also don't have any problem with that bend. I would imagine that it doesn't exceed the radius requirement for the bend. So I don't even have any problem with that part of it. It looks perfectly fine.
The reason why we had to wait is because we needed to secure this first up here because it's going to manipulate this a little bit and we don't want it breaking the seal. So I'm just going to simply stuff that into that hole. So up to this point, the bulk of the panel is set. Now we need to run home runs and get ready to start installing breakers after that. Pretty sweet and simple. Here are all the home runs that are going to be coming through the top of the panel box. Each one of these are going to be secured using a Romex connector. Now this is a 10-3 wire. This 10-3 wire is going to be secured using a 3/4 inch Romex connector, and it's going to have to come through a 3/4 inch knockout in the top of the panel box. And this 10-2 wire, this 10-2 is going to be secured using a 3/8 inch Romex connector through a 1/2 inch knockout. And then each one of these 12-2 wires can be doubled up, and they also are secured using a 3/8 inch Romex connector coming through a 1/2 inch knockout. So we're going to go ahead and fish these down through the wall and secure them to the panel box next. All right, so what I did, I went ahead and knocked all the knockouts out first, and then I knocked this 3/4 inch one out for the 10-3 wire. And I probably could have got away with the 3/8 inch Romex connector, but I figured why not, since I already had one here. So in order to install,
Don't you just love the trade slang? Yes, it is non-metallic sheath cable.
the Romex connector, just place it into the slot with the screws on the outside of the panel, and then you simply just take the nut, push that onto the Romex connector. So it's going to look something like that when it's installed, and as you can see, it's nice and secure. And now for these 3/8 inch.
I will tell you too, though, be careful with your lock nuts. There's two different types of lock nuts. There's lock nuts that are designed to bite into the metal, and then there's lock nuts that are designed not to. They're just flat. So that looked like a lock nut that has the angle nibs that it's designed to, as you tighten it, it will dig into the actual metal. You want to make sure you install those with the nibs or the points pointing towards the actual cabinet, right? Otherwise, it kind of defeats the purpose. It still hold it there, but again, that's, you know, not so big a deal with these non-metallic sheath cable connectors. But at the end of the day, there is a right way and a wrong way to put on a lock nut, even though it will screw on, you know. And there are different types of lock nuts and that type of things. So just bear in mind.
Romex connectors, I use these. They're the snap lock version. They don't use the nut. So to
Meet Connect Teams. Quick and simple schedule.
All right, get back this commercial here.
place them in the hole, and I usually take a pair of needle nose, just kind of roll them back and forth until they snap into place, about like that, and they pivot, so it makes them nice and flexible, so you can twist the wires a little bit if you had to. But as you can see, it's nice and secure, and that's what it looks like from below. And again, these can be found in my Amazon store as well. So now I'm going to fish the wires down through into these Romex connectors after I put all the Romex connectors in these knockout holes. Because there is so much information in this video, I decided to put timestamps in the description below. There you can jump to different scenes, such as how to install ground rods or how to install SEU cable inside your panel box. That way it'll help you save time instead of watching the whole video just to find certain sections you need.
Oh, we're watching the whole video, bro. Trust me, we're gonna watch every piece of it.
Now it's time to focus on taking the jackets off each one of these home runs, and I'll show you how I keep them organized. So in order to strip them, all you gotta do is put your utility knife into the casing or jacket, whatever word you prefer to use, and just go down the home run nice and easy. Don't put.
Yeah, folks, please be careful. All right, don't get all crazy when you're doing this. All right, so I actually strip mine a different way. I actually hold the knife in my hand with the blade like this, and I plunge it in, and then I raise the blade once it's underneath, and I let the back edge of the blade ride on the conductors as I barely lift it up as I pull it down. He's just barreling right into it, okay? So, you know, that's okay. But just be careful. I know you're going to be riding the equipment ground down anyway, but just be careful. You'll be surprised how many calls I've been out on where it creates an arcing issue because they damage the insulation by just getting willy-nilly stripping this stuff off. So just be careful.
Push down real hard to where you cut into the conductors inside the wire. All right, so now all you gotta do is pull that jacket, and now it's gonna go up to where it's cut, right like that, and be sure to get the paper off too as well.
Yeah,
Because there's
don't leave-
paper around the bare ground,
Note to self, don't leave paper on it.
and there's paper around the whole wire. So just go up there, take your utility knife and cut away from the wire. Don't cut towards it, you might cut into.
Oh, I got some trivia for you. Okay. So we're all familiar with everybody that says leave a 1/4 inch of sheathing entering into the box. So this is a cabinet. So if you go look at 314.17 B2, then that's for boxes, junction boxes, pull boxes, and whatnot. But do yourself a favor. Go look at 312 and see anywhere dealing with cabinets where it states you have to have the 1/4 inch of sheathing into the box. And while you're at it, go look at 408 and see if you find it anywhere. But I can promise you that you will find it in 314. I'm just saying. Wrap your head around that one. Okay.
To the wire. Then what I do is take the end of that casing and cut it off, and that has the label for that run. So the piece of the jacket that has the label for what that circuit was, I'll go ahead and take that and slide it back over the end of the black, and then just make a little hook so that way it doesn't fall off. Now I know what this circuit is. Now all I gotta do is go through and do that to all of these home runs. There is such a tool called a Romex wire stripper, and I have not used it before. I have always used the utility knife when stripping these home runs, but I'll put a link to it in my Amazon store if you want to check it out. Again, I'm not sure how well it works, but I'll put it out there for you.
I won't comment on how well I think the one that he showed works because I might be biased, but I'll move on. And it wasn't too long ago that I did work, trim out a panel for a little side job thing. And I will tell you, I still use a knife. I don't use a utility knife like that. I use a regular electrician's knife. Y'all have seen me. I've done a video on it. One of my favorite knives for doing electrical work. And once you get good at it, boy, you can master the control of that blade. But at any rate, there's a bunch of different things you can use. They even have the things you can slide over it and squeeze it and pull it down as well. So there's many options.
Now that I got all the wire stripped that's going to be coming into the top of the panel, I'm going to show you how to install first a double pole 30 amp breaker for the hot water tank. Just a little word of advice, be sure to wear safety glasses. When you're working in a panel box, you got a lot of wire swinging around your face when you're roughing it in, and you don't want to get poked in the eye. Those little copper wires are very sharp. All right, let's get back to wiring the panel box. Before we get started installing this,
and no OSHA comments, please, because this is residential. OSHA ain't never going on this job.
Double pole breaker here, I wanted to let you know that this wire here is shorter than normal. That's because I ordered it too short to begin with, to be honest with you. So I let the most I could out by with a hot water tank. So what we're going to do first is go ahead and take off our label. And now these are the wires that we're going to need to wire into the panel box. So the first thing I do, I'll go ahead and take the breaker and go ahead and install it to where it's going to be permanently installed. So what I'm going to do is clip it into place, and all you got to do is line up these little notches with this little notch.
Imagine this scenario.
Okay, so I'm interested in seeing how easily he installs this.
On this plastic bar, and then it just slides over these two prongs. And just so you know, this panel box is not live, obviously, because we're just now installing it. So if this was a live panel, be sure to kick your main breaker, obviously, but just a word of advice. And again, seek help from a licensed electrician if you're not comfortable with any of the stuff seen in this video. All right, so now we're going to go ahead and slide that over to where it goes. All right, so that's slid into place. And now what I do, I'm going to go ahead and bend these wires here up into the corner. Then they're going to come down and angle right into the breaker. So go ahead and bend them into place. So now we gotta cut these wires to length. So all you gotta do is cut them about right in this area, just enough to slide into the breaker. So about right there. So go ahead and clip it there. And now go ahead and take your breaker out. All you gotta do is pull this way on it and just kind of rock it out of there, just like that. And I'm gonna use a pair of these wire strippers. And to use these, all you gotta do is line whatever gauge up wire inside of whichever groove is associated with that. So there's my 10 wire slot.
All right, Adam, have faith in him now. Have a little faith in the guy. Let's see, he's doing good.
I'm gonna slide that right over the wire. I usually take about a 1/4 inch off. All right, now we take our breaker and use a square drive and back out these screws. And just so you can see what I'm doing here, if you look inside this breaker, as you can see, there's these metal brackets. That's where the wire slides up in.
So this is a good time to talk about these real quick. So some breakers can take 2 conductors. Some breakers only take 1 conductor. These are saddlebacks. So you can tell by the saddleback that it'll take up to 2 conductors per terminal. Of course, they have to be the same size. You can't put a 14 on one side and a 12 on the other side of that single terminal. All right, right? So they have to be the same size. That's not a problem. A lot of breakers allow multiple conductors to terminate on it, so people refer to it as double tapping and all, but not in this case. This one's rated for that. You also can look on the side of the breaker. It'll have a little diagram, give you some information as well, but you can tell these are saddlebacks. So it could be, so you could have 2 12s, 2 14s, 2 10s. It's designed to do that at each terminal. Not a problem here. Again, it's obviously evident he's not going to torque anything. Okay. So again, we don't have to worry about 110.14D. He probably should, but because that's where a lot of the breakdown happens. And like I said, I torqued, again, I reiterate, I torqued most of this stuff, and I had a torquing screwdriver. It works just like my regular screwdriver, but I didn't do it down on receptacles and switches and things like that. But I did for feeders and the services and inside of the service equipment, I did use my torquing screwdriver. And, you know, we didn't start using it until we realized it was an issue, right? These type of things, so.
So if you back this out, you can see it opens it up and allows a wire to go into place. All right, now just slide the white in where we had it originally placed and tighten up that screw on the breaker. And that's just going to wedge it so it's secured. Then do the same to the black wire. Slide into.
Absolutely. So there is torquing requirements marked on that little label that was on the front. It usually will give you the inch pounds, depending on the size, and these are smaller, so they're probably inch pounds. It does give you that value. Obviously, if they give you that value, they expect you to use it. And it's up to you whether you do or not. It doesn't matter what I do now, because as everybody knows, I'm not an electrician anymore, right? I don't do electrical work anymore. What do I know? But it's there for a reason, okay? Just throw that out there.
Place, then tighten up that screw. All right. Just like that. And that's what it's going to look like. So you got your wires that's wedged under each one of those screws, and then just reinstall it to where you originally had it. And now this copper wire goes into this bar here.
He struggled, man.
So you know, this is going to act as a hot wire versus acting as a neutral. I know it's colored white like we're used to seeing, but it's actually a hot wire.
So I'm going to give him the benefit of the doubt, but we all know that that is required because it's in a cable assembly. He has to re-identify that. Remember, if it was in a raceway, you can't do that, okay? You wouldn't be able to. It only works for cables that you can do a re-identification of the white, okay? So because it is a cable, he would have to wrap it at the end, at the termination, in black, red, blue, it doesn't matter. But you don't have to wrap the whole conductor. You only have to encircle it at the termination. So just wrap one piece of tape right around the end there, good to go. There's a lot of people that wrap the whole daggone conductor. You don't have to. The code doesn't say that, okay? So again, it says encircle it at termination. Doesn't say encircle the entire freaking conductor. But you do you, but that's not really what you should do.
All right, so now this ground.
Oh, so the code reference for this is 200.7C1 for re-identifying that white conductor in a cable assembly. Okay, for those that are keeping track and you want to go look it up, 200.7C1 for that application.
We're just going to go ahead and cut that and put it into place as well. So something like that's fine. It's going to go into here.
And all the other people that might ask the placement of those terminal bus like that, you can tell by its orientation. This is a plug-on neutral panel, right? So it's a plug-on neutral.
So go ahead and back out the screw to where you want to place this. And then after that screw's backed out, place your ground wire into that bar like so, and then tighten it up. All right, so that's how you install a double pole breaker. And again, this is 2 hots here. All right, now let's install an arc fault breaker. After I install each breaker, I like to keep the panel box door right beside me while I'm working, so that way I can just open it up. And then right here on this side, inside the door, is numbered spaces, and over here there's numbers beside each space, and it corresponds with each other. So I installed that hot water tank up here, so I come over here to the top right hand side, then I'll just pencil in hot water on each one of those spaces.
That is a good tip though, and he probably looks like he has a pen in his hand, but I always tell, because you know what, doctors are, they write crappy, electricians write crappy, they all write crappy. So if you're going to be doing this and marking them as you go, do it in pencil. That way you can go over it later with the Sharpie, or you can go over it later with pen or whatever, or write it in pencil if you're going to do labeling and you're going to do little labels. They look really professional with labels. They have to be very direct about what room it is, where it goes. Can't be ambiguous. It's got to be very clear and evident. But I'd do it in pencil at this stage, because you can always erase it, or you can actually go over it and make it all look really neat. Right now, he's just making sure he's identifying them as he's installing them, saving him some steps. Again, I'm all about making it look really nice, really good. And James, we already established that he doesn't have a torque screwdriver. He doesn't have a torque wrench. He didn't torque the terminals at the lugs for the service conductors. He's just not doing 110.14D. And he's ignoring 110.3B. So no, he's not torquing anything.
So that way I know this numbered space corresponds with this numbered space, so I never lose track of my circuits. Now we're going to install this 20 amp arc.
No need to be sorry, James. Again, never know when people come in, so all I was doing is kind of giving you that quick summary. But yes, observations are always welcome here. Another question was said about GFCI. Well, I don't know where that's going. We don't know where it's being run. And also, since he doesn't have an emergency disconnect outside, so obviously he's not in the 2020 edition of the NEC. So if he's in the 2017 edition of the NEC, then that's going to vary. And so again, it's not a 15 or 20 amp circuit, it's a 30. He's obviously not in the 2020 NEC, he must be in the 2017. So again, might not be as restrictive on the requirements for GFCI wherever this is going. Okay, so we don't know that, so we can't speculate on it. Only he knows that. Unless he shares it with us, we're just going to assume and roll with it. I'm not going to speculate. All things to consider, though.
Fault breaker. This is what it looks like out of the package, and I'll show
For those looking for an additional income stream on
Okay, well, let's run his commercials here.
you what we got here, how this is different than a usual breaker. If you look here, let's zoom up close here so you can see. So right here is where the hot wire is going to go in, which is the black. It slides into there and gets clamped down. And then, as you can see here, this little silver area, that silver area is where you're going to back out that square drive screw and slide your neutral into there. So these are plug-on neutrals, which is really nice. So if you look here, that's going to hit the neutral bar or clamp down onto it. And then, just like a standard breaker, that's going to hit in the back of the panel, which is going to energize the circuit. So it's a pretty cool design. And
People love those plug-on neutrals, man. We had Siemens on another show that will be aired again at some point on our channel. And we got to meet with those folks. And I think all the manufacturers do them now. But that's the reason that bus bar is configured that way. So the plug on will actually go right there in the convenient gap that you have, as it's just kind of the way it's laid out. But it does save a lot of time, that type of thing.
If you've been following my channel, this is that first circuit that I ran to the room on how to wire a house. So now you're going to see how it's hooked into the panel box. So the first thing I do is I'll go ahead and install this breaker, or not really install it as much as just clip it into place. So we'll go ahead and squeeze that onto the neutral bar and then bracket it into where it goes. So right like that. Again, it just kind of plugs on, hence the name plug on neutral. Okay, now what I do is I'll go ahead and address this white wire first. So I'm going to go ahead and tuck this up into the back of the panel box just like I did the other breaker we just installed. It just gives it a nice, neat appearance. And I'll go ahead and turn that towards the breaker. So I know it needs cut about right here. So we'll go and snip that now.
Yeah, it's clear he's not going to use the cut gauge that's on the side of that breaker to tell you how much to strip. He's clearly not. He's just going to go whack at it. Hey, as long as it makes a connection, you know, he's not going to, you know, he's not an electrician, so.
And we'll do the same thing with the black one now. So we'll go ahead and push that up into the corner, just so we keep everything nice and organized looking. And something like that.
I will say up front that as many videos that I've seen in my 30 plus years of doing this and teaching and educating and doing it in the field, we have a guy that's not an electrician, but he's not that bad. He is definitely not, you know? So, you know, hey, get at it. Everybody has their own way of doing things, so.
All right, then go ahead and clip that to length. And now we're going to take our wire strippers, and this has the gauge, like I said.
In all fairness, Adam, I think he actually does. He's just showing some things, but I think he'll speed up and go on and make all his equipment grounds up. But I would think so. That would be the first course of action that I usually do, because they get tucked back in the back and everything gets in front of it. That's the process. But he might go that route.
And this is 12 gauge, so we slide it into this 12 slot. We'll strip about a 1/4 inch or so off that. That looks good. Do the same to the white.
No strip gauge
And
there.
now
Just
let's
strip
address the ground. Same thing, slide it up into the corner, and then we'll go ahead and turn it in towards the bus bar. So we need to clip it about right there, and we'll go ahead and snip it. And then what we need to do is we'll go ahead and pull this breaker out. Okay, and we'll install the wire in the corresponding slot it goes, and these are just square drive screws as well. So we'll go ahead and back that out and slide that into place.
No doubt, Randy. It seems like he had trouble cutting that 12.
Now we'll do the black next, same thing. Just slide it into the slot it goes in. The slot I just showed you up close a moment ago. Hold it into place, tighten down the screw. All right. Then I'll always double check to make sure they're in good. Yep, that feels really good.
That's a manual
Now,
torque
we're
wrench.
just going to install that back to where we took it out of. Go, that looks good. And now for the ground wire, same thing.
I agree, Adam.
Just go ahead and back out this screw, slide it into place, and then tighten up the screw.
Now, most people that knew me, that worked with me, and well, here's what many people don't know, and you could Google it. I won the National VICA contest back when it was called VICA. Now it's Scholastic something else. Now it gets on TV. But I won that back years ago, and actually back in '87. And and I'll tell you, I always had a severe case of OCD. And when things aren't level and straight and nice and neat, it drives me crazy. So I get it. And my guys, it used to drive them crazy because, again, I did play Monday morning quarterback with my guys. I'd go to the job or something. I'd go, dude, why did you? They're like, Paul, it's okay. I'm like, you know, because I was OCD about these type of things. Okay. On my cable, you could put a level on it. I mean, I didn't have to work at it. It became natural. So when I competed, and I used to do that when I was in school, in my vocational school, I competed and won the regional, then won the state, then won the region, and then won the national. Was in a residential installation in a mock-up building. And I was very anal about how I ran my stuff and how it looked. He doesn't care as much, and maybe he'll make it look neat at the end, I guess. But that stuff always drives me crazy. Doesn't mean it'll work any different, right? Workmanship, it's in the eye of the beholder. What looks good to somebody else may not look good to somebody else. Doesn't mean it's not good workmanship. What ends up being poor workmanship is if you route conductors, example, across a live bus, or you haphazardly install conductors across live buses or orient them in a way that isn't in good workmanship. But again, making something neat or straightening out wires or doing this, you really can't cite workmanship on that. Again, it's in the eye of the beholder. If it doesn't look good to you, then you just don't do that. But again, just things to think about.
True. And now I just tuck these wires in to make sure everything looks nice and straight. All right, and that looks pretty good.
Yeah, he will need fillers.
And now that's all there is to installing an arc fault breaker. Again, very easy to do. The plug on neutral keeps everything real nice, no pigtails. So up close, that's what it looks like installed.
See that?
There's
that equipment. See, that would drive me crazy. I get it. It's fine. I get it. But you've got all that wire. I'm just saying. That's just me. I'm sorry. Doesn't mean it's not workmanship. Doesn't mean it's not good. I'm anal like that.
the ground wire, and here's how you kick the breaker on and off. Pretty simple and straightforward. I wanted to make sure I showed you that arc fault only breakers are going to have a white test button, and the GFI Plus arc fault breaker is going to have a purple monthly test button.
All right, a couple observations. That's just a square D, right, Schneider? These colors will be different depending on the manufacturer, so don't let that be gospel to you. He's using the home line square D, and again, but there is no standard for color coordination for this, so just keep that in mind.
And just so you know, they're wired exactly the same. So if you know how to do an arc fault, you know how to do an arc fault GFI combo breaker. These are
all right. Let's make a statement. Let me back up a little bit on that right here. So hopefully you know there is a difference. So he says combos. So an AFCI, GFCI, that's called a dual function. A combination AFCI is a device that sees both parallel and series arcs. So if you think about it this way, if I have a piece of non-metallic sheath cable and I have a black and white running parallel, and I get damage across those two conductors, then that's a parallel arc. If I run a conductor and I make a bad termination where I don't torque it properly, or it gets damaged where the conductor's got a break in it, yet when current is being drawn through the circuit, there's a load on it, then you get an arc across those conductors. That's a series arc. Okay, that happens at terminations, and if you improperly terminate it, that's what happens when you don't torque. Because if you don't torque, then what happens is if it's a loose connection, it can be as bad if you over tighten it, but it can be just as bad if you under tighten it, and it can create an arc, and over time it builds up heat. So that's the importance, at least in these areas, of making sure you use torquing screwdrivers and torquing wrenches, okay? That's the last I'll say on that. But I need you to understand that an AFCI combination is looking for two different characteristics of arcs, both parallel and series arcs, okay? A dual function AFCI is one that covers not only the GFCI requirements for personal protection, that's the 5 milliamps nominal, but it also covers series and parallel arcs together, that type of thing. So I just want you to know the difference. There's a different types. There's a branch circuit feeder type AFCI that does not provide for series arc protection. That only provides for parallel. But the combination AFCIs does both series and parallel arcs. And then a dual function AFCI covers both GFCI as well as AFCI functions. Okay, so that's just one of, and the color coding again can be different depending on which manufacturer you're dealing with. So again, don't take these colors as gospel. He likes to use Schneider. I'm an Eaton guy, so I mean everything's a little different. So
have a purple monthly test button. And just so you know, they're wired exactly the same. So if you know how to do an arc fault, you know how to do an arc fault GFI combo breaker. These are the lug covers that came with the panel. They're real easy to
Dual
install.
function.
These just slide over the cable, and then this goes over the lug. So just like this, pretty simple. And then each one gets it. And it's a nice safety feature. That way you don't accidentally bump into these.
Okay, so these are required in the code under 230.62C. It used to be under 408, but it got moved here in the 2020 edition because this really only applies to services. You don't need it on a feeder. Why? Because you can turn the breaker off and put that downstream panel in a safe condition. So again, here you can't really turn it off. These conductors are going to be live from the meter, right? And so again, you can't turn this off. So that would be a problem. So that's what these are for. So again, this applies to service conductors here in this panel. It apply to switch gear because now that's in 230, it's broader when it comes to services. It no longer has to apply to things like feeders and whatnot like that because you do have the ability to shut that off for a feeder, right? So makes sense.
Even though the breaker's off, these are still going to be hot, FYI.
And you notice that that breaker is a horizontal. That means it doesn't matter in this case which way you up or down that you orient it, okay? Just have to be careful. Now, if you were to put this on its side, like he said earlier on, then you do have the issue of which way is on in the up position. That could be a problem because, again, it then turns that horizontal to a vertical. And then you also have the issue of the breakers. The ones that can be on in the up position, you could use. The ones that are not, you could not use. So it limits your use of that panel board. So why would you do it, right? Just throwing those things that we talked about earlier, just making sure you re-up those as we move forward.
Now that I showed you how to install those couple breakers, I wanted to show you what I like to do with my ground wires.
See,
I'll
he
go
already did
ahead
them.
and take every ground wire, run them into the back side of the panel like you see here, and start plugging them into this bar. So that way it keeps them all looking nice and organized and tucked away in the back before I start running my blacks and whites.
There you go, Adam. He tucked them all in, so he took care of it.
And as you can see here, I have all the wires stripped and ready to go, and I have them tucked to the side here so that way they're not in the way as I try to install all of my breakers. And you might want to do things like this, like I had this extra ground wire that was left over from the grounding rods, and I used it just to hold the wires back so I can work in the panel. And I also like to show you, always keep a place for trash and a place to put the scrap copper. So in case you want to turn that in for scrap metal, you can. And then I'll have my panel box cover right here to the side so I can fill it.
If you guys and gals watch my commentary series on residential that me and Jay do, you'll know that it'll need a much bigger bucket than that, because that guy who does that residential series that we do, he has a lot of scrap. He leaves, what, 2 feet of scrap at the end of each box. So I'm saying he'll fill up that bucket in no time, okay?
Out as I go, and then I have my breakers sitting right here so I can just reach down, grab them, and keep running the circuit. So I have a nice little system going, and it keeps things flowing well. And right here, I wanted to point out to you, I had to bracket and secure each cable 12 inches from the box, so I went ahead and done that, and then put some strapping here to keep things tucked away. And then up above, the same way, I went ahead and stapled all the wires going across and put.
Okay, so his strapping and all is in accordance with the NMB 334.30. He's done within 12 inches. We're good. He's done all that. I will notice that as he goes to that top plate, he did not need to put those nail plates in, but you know what? He's being very proactive here. That's the last place that I want a sheetrocker to start driving some long, they don't always use the right screws, right? Drywall screws, sheetrock screws. This is just an extra nail plate here or there for a pound of prevention. Although I did want to point out that 300.4 would not require this unless the board hole was less than 1.25 inches from the edge of the board hole to the edge of a framing member, and that applies to both sides of that framing member. He doesn't look like he is here, so not much of a concern with that. And we won't get into any adjustment and corrections based on one of those holes up here. It looks like one big hole with more than 4 NMBs coming through it. We're not going to get into that because I really can't tell. And I'm sure he's going to rock wool those or seal those to maintain the rating 300.21 for that penetration. I'm sure he's going to do all that, or somebody's going to do it. So we're not going to get into it when it comes to adjustment and correction, because I really can't tell how many he's got going through there. It looks like that one hole might be one hole, but it might be two separate holes. So better than speculate, we're just going to move on.
Put some nail plates here to protect those wires from any kind of nails or screws the drywallers might be in placing into the wood.
They're cables.
And now what I'm going to do, I'm going to go ahead and keep running these breakers, and I'll show you what that looks like when I get towards the end. And these cables here are for a sub panel, so I'm going to show you how to do that as well.
Subby, bruh. Jay would like that. Let me say, Jay would like this guy, even though he's not an electrician. He likes his editing skills, you know, just speeding things up.
If you're curious to know how much time I had from the time I started this video to ending it, it took about 2 days. It took me 1 day of actually putting the ground rods in, putting the SCU cable in the panel box, setting the panel, then about another day hooking up all the breakers and putting all the final touches on everything. I figured you'd want to know that information.
All right, before you comment on his time, and Jay would say, dude, this guy's fired. He was shooting video and he was by himself. So this is why I never want to support somebody that works for me in their TikTok channel or their Facebook channel or their YouTube channel. If it takes you 2 days to put these in, cut this in, and drive those ground rods and all that, yeah, we're going to have a problem. But, you know, he was shooting all this video so that you can learn from it and we can comment on it. Again, we're a team here. But again, probably a little too long to this. Because I probably, and you're going to snicker, but back in my day, this house looks like the size, about 2.5, 3 days, I'm expected to be done with this rough-in. But at the end of the day, the reason he took longer, he's his one-man show. He's doing the video. He's taking the video. Give the guy some slack.
All right, this is what I got done so far, and I wanted to show you something that's unique. If you look at this dryer breaker.
Hi, I'm Charles Payne. On TV, I report on the market.
By the way, I love Charles Payne, but we're going to skip you, Charles.
Double 30, just like the hot water tank that was a double 30. If you remember right, I got the white for a hot and a black for a hot, then the ground went into the bar. And now if you take a look at this dryer, this is a double 30 also, but you have a red that acts as a hot, a black that acts as a hot. Then you also have this white that goes into the neutral bar, and you also have its own ground that goes into the neutral bar. So that's a little different. This is ran with 12-3 wire, just so you know, for the dryer. And
he caught himself, relax. He caught himself.
And now this is what I got done so far, like I just said. And I wanted to go ahead and wire up this 100 amp breaker that's for a sub panel. And I wanted to show you something here. I had to add a neutral lug here. Now what this does, it ties into both of these screws and gives you a bigger area to fit.
So this is why I'm impressed with him, even though he's a homeowner or doing his own job. I can tell you that there's a lot of electricians who would have taken that neutral and separated those strands and put half under one lug and half under the other lug. Don't do that. You can't do that, okay? Because then current doesn't distribute evenly at the termination. It creates a hot spot. It needs to run that. So he knew enough to go buy a lug like this, which is basically a forked lug that's going to go into each one of those openings and torques it and tighten it down. So you got to give the guy credit for that, right? Because I know, and you know, some electricians who would say, oh, well, just spread up the strands, and don't do that. Okay, there's a reason why you can't do that, because of how current distributes on it and how you distribute it out at termination, where it's going to be ultimately probably your weakest link in the component is at its termination. So again, I like that he did this.
This larger neutral wire into. So I'll put a link in my Amazon store to where you can buy one of these. But also this is the ground that's for this 100 amp cable as well. Well, for this 100 amp circuit. This is number 2 aluminum wire, and as you
Uh-oh. Okay, hold on. Okay, code time, folks. So he said that was a 2 aluminum, and it's a 100 amp breaker. All right, we're gonna have to go to code here because I got to show you something, because this is probably done all the time. All right, so here's the thing. All right, that's a 2 gauge aluminum. What's the ampacity of a 2 gauge aluminum? Let's do this. Okay, we're at the code, right? Let's go to ampacities just so we can do it. And let's go to 310.16 just so we can see what we're looking at, because he says he's running a 2 and he keeps saying 100 amps. Okay. And oh, by the way, don't you stop at 310.12 because he's running this to the garage. Not going to be applicable. Okay, so skip on by that. Or for you in the 2017s, 310.15b7, skip on by. That's not what he's running that remote distribution panel to. It's to a garage. All right, so let's go on down and let's look at ampacities. All right, so it's running a 2. That would be over here. It's good for 90 amps. 90 amps. You also would go to 240.6a and look at the standard size overcurrent devices. There is a 90 amp rated overkite. We don't, voltage drop's not a requirement, so we're gonna assume that, you know, and it's 240, so it's probably not that far, so it's probably not gonna be a big deal. Voltage drop's not a requirement of the code, it's a recommendation. Other than for fire pumps and sensitive electronic equipment, you don't have to meet the voltage drop requirement. I encourage you to meet it, but it's not a code requirement. It's a recommendation under an informational note. But usually in a 240 volt application, it's not gonna be that big of a drop that it's that big of a deal. But things to always consider. Thanks for pointing it out. Now, here's the thing, and we don't know anything about that garage, so I'm sure it's detached. The way he's running it, I'm sure he has to establish a grounding electrode system. Again, I'm not going to speculate on that. What I will tell you is I'm going to comment on what's given to us. It's a 2 gauge. He's using an SER. It's a 2 gauge, and we know that he's leaving. He'll tell you in a minute, because I saw this. But this conductor is only rated for 90 amps. And since they make a breaker that's rated for 90 amps, that 2 gauge aluminum has to terminate on a 90 amp breaker. It cannot terminate on a 100 amp breaker. This is a classic example of what happens at your Home Depot and Lowe's when the guys in the orange and the blue, they sell you the cable and tell you it's good for 100 amps. It's only good for 90 amps. It's not good for 100. It's a 2 gauge. 2 gauge is good for 90 amps. 75 degree, okay? Terminal limitations. So again, you don't terminate that on 100 amp. So just be aware of that. And if you say, well, wait a minute, do they make a 90 amp overcurrent device? Right? I mean, if that's what you're saying to yourself, do they make a 90 amp overcurrent device? Well, let's go to 240.6 really quick so that you show that you have to protect a conductor at its ampacity. We all know that, those rules, 310.15. So let's go to 240.6a and just see what it says. Oh, look at here. We have a 90 amp device. So quick fix. Pull out that 100, put a 90 in there, go to town. You know what I'm saying? Does it matter if the breaker in the remote distribution panel is rated 100? No, it doesn't matter, because at that point I doubt those are 90 degree rated lugs, bruh. Joe, when's the last time you saw a 90 degree rated lug on a residential panel? All right, but I get you. All right, so at the end of the day, and we also got to remember what? That 110.14c talks about whether you use a 60 or you use a 75. It says that you can use a 90 for adjustment and correction purposes as long as at the end of the day you don't exceed the value of the terminal limitation. All right, these panels, these lugs, this equipment is 75 degree rated lugs, but it's usually going to be marked 60/75. I have never seen a residential panel with 90 degree rated lugs, ever in 30 some plus years. Okay, but you knew that. All right, so he needs to change that out. Okay, plus he's also limited by the weak link, and since he's terminating that into a 100 amp breaker, which would be a 90 amp breaker, I can guarantee you that circuit breaker's listing would be 60/75. So he's still screwed either way he goes. Now, whether the inspector catch it, who knows? Because he said he's never failed an inspection. So so there you go. All right, where was I? I got off on a tangent there, but that's a biggie. You know, I've seen plenty of inspectors get gig for that. So pop it out, put a 90 in there, you're good to go. You have to protect the conductor at its ampacity, that type of thing. He didn't have any that type of thing. So, okay, all right. Let's see, where am I at? Oh, let's get back to the video.
You can see it has a ground, a neutral, and 2 hots. And this is going to be for the sub panel in the detached garage when I go to build it, but I'm going to wire it now because
he says a sub panel in a detached garage. So we've got the answer to that story. Of course, you do know detached garage has to establish a grounding electrode system. At that, you know, and you got to run 4 conductors out there. We don't have to have an improper case of neutral. So again, 250.24A5 will tell me that I can't have an improper case neutral, 4 conductors. That's what he's doing. He just got the wrong ampacity. He needs to fix that breaker.
because it's way easier to do it now than later, is going to ultimately go into the crawl space and terminate into this box. This is a junction box, and we're going to transition into conduit and then run it outside under the ground into the detached garage when I get to it. But this is just a clamp that's going to hold it into place. And again, that's in the crawl space, but I want to go ahead and show you before I installed it under there. So
now I will tell you, because this is a perfect segue, right? Perfect segue. Well, we knew it was going to be detached, bruh. Come on. All right, so perfect segue into my hybrid cable that many people have probably heard of. I'm the inventor of a hybrid cable. It's only available through Encore Wire. And it's a tray cable and an SER cable. The significance of that is he needs that junction box, right? He wouldn't if he used the new hybrid cable. My hybrid cable was created, and I created it and put the best attributes of both tray cable as well as SE cable, so that you can go straight from this panel as SER down in the crawl out into the ground. It magically changes over to tray cable. Tray cable can be direct buried, but SER cannot. Once it gets to the next structure, it then comes into the building and terminates on its disconnecting means as it's required at that structure. And now it becomes SER again. So it goes from SER to tray cable to SER all in one length. And that's the beauty of my hybrid cable. Again, only available on Encore Wire. Check with your local distributor and tell them you want Encore Wire, because they have the most innovative guy that works for them that has a patent on a special type of hybrid cable. Best of both worlds. Okay, I'm just saying. Enough of that commercial. But you need to get you some. It's amazing stuff, if I do say so myself.
I already clipped the 100 amp breaker.
Oh, by the way, I don't make any money for that, and I don't have any money coming in on the patent, and it's owned by Encore Wire, even though I invented it, and you get my point. I don't make anything on that. Yeah, they do pay my salary, so I guess that, there you go.
Into the panel box. So what I'm going to do now is address this neutral wire first. So, like I said, I already got the lug installed. So what I got to do is go ahead and bend that back into the panel box where I want it, and always like to try to leave plenty of excess in the panel box if I can. But let's see if we can get that placed to where we want it here. And these things are pretty stiff wires, and it's a little cool out today, so it's a little harder to work with them compared to normal. So we want to clip it about right there. So I'm just going to take my pair of wire cutters and then go ahead and snip that off right there. So now what I got to do is take a utility knife, come back about 1/4 inch and just cut around that casing. All right, now all we got to do is flex this into that lug. So we'll go ahead and wrestle with it here a little bit and get it in there. All right, now kind of hold it in place and tighten that lug down. And now when you tighten this stranded wire down, you're going to have to snug it up as best you can. Then after it's snug, give it a little wiggle and retighten it down. And that's just because those strands will separate some whenever you wiggle it.
So remember, folks, most of the aluminum today is called compact. So the strands are trapezoid and they're interlocked. There's no interstices, there's no voids, there's no gaps. So when you tighten it, you should torque these. When you tighten it and then you wiggle it and you tighten it again, what you're doing is over compressing the termination, and you just continually over compress it. which can be just as bad as under torquing, okay? Damaging it either way. So again, the old elbow system where you do keep tightening. And you will see the irony here, because I will tell you the breaker does not get any antioxidant compound, yet he used it on all the other lugs, and he didn't use any here either. So again, that's why I tell people, they don't know why they're using it. They just use it. And we explained earlier that it's not required unless the manufacturer says it's required, and not the wire and cable manufacturers. We don't care. We'll give you a recommendation. We'll tell you to use it. We want to protect our interest. It's our wire. Reality is all this equipment is tested without it, unless the equipment specifically requires it. He's choosing to put it on the lugs, but he's not using it here. Okay, to each his own. But again, it kind of explains that people really don't know when and why or if you're supposed to use it.
So go ahead and wiggle it again, and then tighten it down one more time.
Just crush it. Go ahead. Just crush it.
And now the next thing we need to do is do the same thing for the hots. I already got them this top one the length, and then this one looks good as well. So same thing, we got to cut about 1/4 inch back off the sheathing. And now I'm just going to back out the slotted screws that's on the 100 amp breaker. Then we're just going to place it into the breaker.
Somebody ever cared how I strip those? I actually take my side cutters and lightly use it and score it with my side cutters. And then I take my knife and put it in the little score and then pull it towards me, and then the rest just peels right off. Just how I do it. Or how I used to do it when I was an electrician.
On it and then tighten that up. And again.
Hey, it's Brian from Samcart, and if you're someone who's
Okay, another commercial. Dude's making a killing off this one here.
Give it a little wiggle and then tighten it again. For those of you who have installed sub panels before, let me know how your experience was with that in the comment section below. All right, now we got a 100 amp breaker that's going to feed our sub panel in our garage. And again, here is the powers. This is the neutral coming in, and then here is the ground. For anybody curious about the 262 wires in my breaker box, they are for my HVAC units. One is for my outside unit, and one is for the inside furnace. And the outside unit could have got away with a 40 amp breaker, but I went ahead and put the 60. They said that was the max amperage breaker I could put in there. Just for anybody curious, and the other inside unit breaker is a double 30, ran with 10-2 wire. All HVAC units are different and require different size breakers and wires, so I just wanted to put that out there. This is not a universal setup you see here. Now,
all right, so one of the comments about that is people immediately will start doing amps and looking at amps and how they have the application for it, right? And so he may not. He depends on what code cycles he's on, whether or not the GFCI is required, right? He might be on the 2017, not on the 2020 when that came into play. So we don't know. We don't know. We're going to assume since he didn't put the emergency disconnect that he's on the 2017 or earlier. We don't know. So we're not going to speculate. But what I will tell you, and man, you made me forget what the heck I was going to say about the guy. For air conditioning units outside, again, it's all about the nameplate, and 440 gives us direction on that. I have a podcast that explains that, how that came up with those values. But if you look on a nameplate for an outside air conditioning unit, it's a minimum circuit ampacity, maximum overcurrent protection. And then it'll tell you whether it has to be fused or circuit breakers or either or. But just follow the information that's on the nameplate. So don't get freaked out. And some people do if they see a 60 amp overcurrent device and they see this is an extreme one here, but a 10 gauge wire. Okay, you're sizing the circuit, the branch circuit for minimum circuit sizing or the minimum circuit ampacity, and you're sizing the overcurrent protection in accordance with what the nameplate says. It's okay. It is all founded in the rules in 440. It's just that it's been retranslated by the manufacturer and done in a nameplate so that all you have to do as an electrician is just look at the nameplate, follow the nameplate, keep it simple, stupid, and there you go.
Now that all the breakers are installed in the panel box, it's time to work on this panel box cover. So all you got to do is anywhere you have a breaker, come over here and take the corresponding twist out in the location in which that breaker is going to be placed. And there's something unique here in this situation if you remember, I started from the top and was working down, and this cover came missing 1 and 2 here. So I'm going to have to get what's called plate fillers, and they just go over these areas. They're little black pieces. I'll show you a little picture here. That's what they look like. And they just snap in and just fill in these places where they're missing the twist outs. So I'm going to show you how to take these twist outs out and install this cover. In order to remove these twist outs, you simply just take a pair of pliers, kind of grip onto it, and then push back, and then wiggle it back and forth, and then just work it out just like you would any other knockout, but this is called a twist out, and then pull it, and now you got a space ready to have a breaker installed. Okay, I just set the panel box cover over the breakers, and it's hard to record it, so I just went ahead and placed it on there. So now the screws that came with the panel box are right here.
Blunt tip screws, use the ones that came with the manufacturer. Do not try to use any other screw with a point on it. You know that. We all know that.
It's these, they look like that. And now each one of those goes into the holes that's in the middle and each corner of the panel box cover, and they just take a square drive.
You ain't lying, Matt. You talk HVAC and breaker and conductor sizing on a Facebook page or a Twitter page or Instagram page, you can literally hear heads exploding around the country.
As well, the same square drive size that the breakers used. Then you literally just place the screw into the hole and tighten it up. Not very complicated. The only thing out of this whole process that wasn't very complicated. After you get all these screws on that's going to hold the cover on, let's take a look inside. This is our ledger that tells us where the breaker is located for what circuit. As you can see, I still need to get these filler plates for these 2 locations here. Here's the main breaker to kick the whole house off and on is right here. And that is what's going to look like on the inside, nice and clean. And that's all there is to installing a panel box. And I just wanted to let you know that for the dishwasher, I need to get what's called a padlock attachment. And what that does is lets you lock out that whole breaker. So if you kick it on, it.
So the panel's obviously not within sight of his dishwasher, so he's using this lockout device.
Puts a padlock so you can't turn it off or on either way. And that's if you're working on the dishwasher, it's safer that way for the electrician. And the same thing goes on the hot water tank, but that's going to be for a double breaker, which is a little different lockout. All right, guys, I want to say thanks a lot for watching. I hope you learned something. Be sure to leave a comment below if you have any questions about this video.
Okay, let's go back to me. All right. Hey, all in all, I think the guy did a pretty good job. You know, some of the things he's not familiar with the terminologies. You get that. Not bad. Yeah, a guy like that I can work with, right? Right? So, I can work with a guy like that. I can take him from being good to a superstar, right? All he needs is a little code. You know how I tell people all the time, anybody can learn to do stuff with the hands. Look at this guy. He's not even an electrician and he does it. But now it's time for him to step up his mental game, and that is to learn the National Electrical Code. And that's what everybody does where? Right here in this Fast Tracks program. So if you're interested in learning more about the National Electrical Code and you want to get into a structured program to learn the code, there you go. If you're already licensed and you want to learn residential, commercial, industrial, grounding and bonding, we have courses that are called post-licensing courses. We encourage you to check them out. We appreciate all of you following. I hope you got something out of this coffee hour. I can tell you right now, I'm out of coffee. We're done. I foo-fooed my coffee. It was just some latte. You know how I roll. I'm not an electrician anymore. People say Paul can't do, he can only teach. All right, well, till next time, folks, stay safe. God bless. And again, thank you for joining me on another episode of Coffee Hour, which was almost coffee 2 hours. Take care, everybody. Stay safe.